record to the okay. So today we'll be talking about Numpy. We're finished with introduction to Python, which so mind you, what we've covered so far in Python is not everything about Python. So you have been taught and brought up on the basic things you would need, the aspects of Python you would come across probably on your day-to-day activities if you have to deal with data analysis or data science. Now, it doesn't mean you should stop there. I want you to know that it doesn't mean you should stop your learning there. So there are other aspects of Python that might come in handy. Why I say so is most times there might be very few organizations, especially in Nigeria, that might expect you to do more than just what a data analyst does or what a data scientist does. So sometimes they might also want you to be involved in, some other core programming projects. So knowledge of that. Now, when I say knowledge of that, if you're a data scientist or a data analyst, you must not know those ones in detail, but a knowledge of that wouldn't harm you. I always have this approach towards life. It's better to have something and not need it. So it's better to also have a skill and then not need it than needing a skill and realizing that you don't have it. So if you have the time, expose yourself to some other aspects of Python. Know it, not as a professional, but just, be conversant with it, maybe terminologies or some words, and, just have an idea of them as you progress. So we are done with the introduction. Now we're going to go into specific packages, libraries kind of. So if you hear library and package, we'll be interchanging the words as we go forth. So today we'll be talking about Numpy. So Numpy basically is numerical Python. As the term explains, it's the package that deals with numerics. So working with numerics, numbers, either integer or floats. So it's a package that's developed. It's open source, like we talked about Python. It's open source, so people contribute to the library, I say warehouse or repository. So Numpy was designed to be able to help people perform certain mathematical tasks and some other things easily. And now let me also explain why, in my own knowledge so far, why some people design packages or build packages with certain methods and functions embedded in them. So there are things you do. Okay, for example, there are certain tasks you want to do that your for loop can do for you, or your if-then statement. So we're talking about your conditional statements and iterations that can do for you. But when it now comes to large-scale production, where resources are to be considered and time, those methods, that's basic way of writing those algorithms or using them is not considered optimal. And when I mean optimal, I mean it is not giving you the best of everything put together. So now when I say large scale production, you're not just talking about functionality, you're talking about speed of output, speed of processing. You're also talking about memory space, which is resources. So nowadays, that if you have like huge project that require a lot of resources, maybe on the cloud, require some particular kind of CPUs or GPUs for processing, you would want to use as little as you can to reduce cost. So when you are able to figure out a way that can achieve, balance maybe the three common parameters or variables or you consider in projects, maybe, like I said, cost, resources, time, that's when you say that's optimal. So it's the best performing version of all the options you have. So that's part of why Numpy 2 is considered very good. It gives you what you call optimization of certain things you would have done with your core Python that would have taken you more lines of code, more resources based on memory allocation and space, time of processing. So we'll see that as we go along with the scripts. So I'm going to share my screen now. I'm going to share my screen so that we can get started. A minute, please. Let me see. Okay, so here we are. Let's see. So this is Numpy. Numpy is numerical Python. It's an open source library developed for working with arrays in Python. Now, arrays are, I don't know how to put it, but arrays are basically a kind of data structure. If you remember, we talked about lists, we talked about dictionaries, we talked about tuple, we talked about set, and we talked about what else? Okay, I can't remember. Now, the simplest way I can explain maybe data structure is, so sorry? Take for instance.
It's a dictionary.
Yeah, I mentioned dictionary, yeah. Take for instance, we're talking about houses, right? You know, I'm thinking of a way to explain it to bring it to reality. You know, there are different kinds of houses, structures. Now, they are all houses, which we know within them probably contain rooms, sitting room, your dining room, your kitchen, and restroom, all that. But how do you differentiate easily is probably from the structure, the outlook, what it looks like. So you have terraces, which some people call townhouses, because once you see houses or apartments that are attached to each other, you know that those are terraces, those are townhouses. So if you see, standalone that is very big, or this is probably a mansion or a duplex. If you have one that is just the ground floor, that's a bungalow. I'm just giving. So these are structures that help you to tell, from the shape or the arrangements, what this exactly is. So that's what data structures are. So it's a way data is put together. So like physical outlook of it, or how it's also stored. It's kind of to say that's the data structure. So in programming, usually you have different types, depending on the programming language. So in Python, you have your arrays, you have your data frame, you have your vector. You also have a vector. You have your vector, you have your, which make up your arrays. So you have your arrays, you have your vector, you have your data frame, you have your, I'm sorry, the name is escaping me. What makes up your data frame? We'll come across that when we go to pandas. So these are data structures. And as we go along, we'll understand what they are. So like I wrote here, it's a container that can hold more than one item. So for arrays specifically, arrays are like your lists. They hold more than one item at a time. But the difference is that arrays must hold the same data type. Unlike your list can hold a list within it, a dictionary within it, a numeric, and even string all together, Boolean. But your array holds just the same. So if it's holding strings, it's strings all true. If it's Boolean, it's Boolean all true. If it is numerical, it's numerical all true. And within numerical, if it is integer all true. And that's what you call homogeneous. Homogeneous is something that has the same characteristics. Unlike your list is called heterogeneous. And then they are ordered. Unlike your list that the order doesn't really matter. So you can move them around and everything. But your arrays are ordered, like I think a tuple. So you see, one of those data types that we did, those ones we did. So array is like a combination of a couple of them put together. Now, you might want to ask, okay, list holds multiple items, just like array. Why would I bother about array? So the explanation I have here simply is, array holds large amount of data and they hold it compactly. List will not be able to do that. So when you're not talking about much data, large data, arrays will do the work for you, unlike a list. And also a list, if you want to iterate through a list, it takes you longer because you go through the items one at a time from what we saw. So when we worked with lists, remember, we couldn't just multiply. Let's say you have a list of 5 numbers. We couldn't just multiply all 5. You have to probably loop it to create another list that holds the multiplication result. But array doesn't work like that. So arrays are, you are able to perform a task or a mathematical function on it. So it's like, as it is, like a picture, you can pass a mathematical function that is carried out on it once. So it doesn't go through it one by one to, maybe calculate this one. So it passes it at once, and at just once, it passes the data it contains, elements, and exacts the same maths or calculation or whatever function you want on it together. How it's able to do that is based on the memory, how it's stored. So here you have what you call locality of reference, which is what the method of storage for arrays. So everything, every element in an array, no matter the size, is stored together in a that's within the same space in memory in a continuous place. So when it's being accessed, they're accessed together, unlike a list. So you see, it takes lesser space, and then its computation time is much, 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 much faster than a list. And that's what you call optimization. So for projects, for large-scale production, or even for simple things, if you can have it passed in as an array, that's the best bet for you, except where you want to warehouse more than one data type. And it's a simple, you can use a list. But when we come to data frame, we also understand how a data frame is used in place of, instead of a list for multiple data types. Now, Numpy, because it is to work with arrays, now holds functions or methods that you can pass on an array. Mathematical functions, we'll see a couple of them we'll use along the line. It makes it easy for you to write, to work with, unlike your list. Yeah, I've explained it. Now let's go to what a NumPy array looks like. So you have different dimensions or outlook of a NumPy array. You can have it like just a list, just a single line of elements. You can have it containing rows and columns. You can also have it containing sheets. What I mean by sheets is, so having one sheet made up of rows and columns, just like your regular table in Excel, you now have multiple of that sheet. So I'm going to illustrate so that we can have a pictorial representation of what we're talking about. How they are called, you have your one-dimensional array, you have your two-dimensional array, you have the multi-dimensional. So anything from two is multi-dimensional. So you have 3, 4, depending. But the most common ones you will find are your one-dimensional, your two-dimensional, and your three-dimensional. Now, if you talk about sequence, so usually if you have just one number, let's say 43, as an element to be used, in this context, it's called a scalar. So it's just existing by itself, one item being held. And somebody can say, oh, it's a zero-dimensional array because there is no length, no width, it's just existing. Now, once it starts having dimension, either length, you understand, or let me see if I can illustrate, please. Just a minute, let me connect this. That's good. Okay. Excuse me, please. Right. So here, can you see the whiteboard?
Yes.
Okay.
Yes, ma'am.
Okay. So when you have just a number like this, oh, sorry. when you have just a number like this, let's say 42. This is what you call a scalar. All right. Now, when you have just like your regular list, I have 1, I have 2, I have 3, I have 4, I have 5. These are multiple items. Mind you now, there is a coordinate kind of. So if you remember your elementary maths, so I think secondary school maths too, where you have your graphs, you have X, Y coordinates, geometry, yes, that they'll tell you, oh, direction. So it's like geometric direction. You have, if it is this way, you understand. So meaning, I think this should be X. And this is Y usually in your graph. These are directions of, it depends on what field, if it's physics or elements that exist, right? So this is where you have, when you have one item like this, you know, it doesn't have like another coordinate Y, nor X, it's just existing. So this is a scalar, the minimum unit. But once you have this, so this could represent, this is just one direction. It's one directional, that's the storage is one directional, or the structure is one directional. So this is what you have. This is what you call 1D. It's one dimensional array. Now, when you have it in 2 dimensions, so what 2 dimension means now is I have rows and columns now existing. So I have 1, probably 2, I have 3, and then I have 4, I have 5, and I have 6. There is a direction here, and there is here, depending on what, however you want to do it, you can also, you understand. So a 2-way direction. So meaning sometimes you might even, some people might say it has length and it has width, or y-axis and x-axis. So this now is a 2-dimension. It's in 2 dimension.
Array.
It is a 2D array. This is a 1D array. Now, when you now have, so I have, this is my first sheet, just as I have it. I have 1, 2, and I have 3. I have 4, 5, and I have 6. Then I have another sheet, just the same, 2-dimensional. I have maybe 7, 8. Excuse me.
12.
Then I have 10, 11. This is now 3D. So in some ways, we're not diving deep into math. So it's like saying there is a third coordinate. So this could be your Z.
3-dimensional.
So this is now 3-dimensional. So this is in 3 dimensions. Having 2, so the first one, it has its length, right? It has its width, and then it has depth. In this case, 2. So if you have another sheet again, the depth increases to 3, and so on and so forth. That's why you now have multi-dimensional. If you've ever watched the 3D TV or a movie 3D cinema or at home, that's the same concept, 3-dimensional. So your regular TV without the 3D effects is just a sheet. So you're seeing it, you can't see anything roundabout. But once it's 3D, that means you're seeing beyond just that flat surface. And now they even, I think they have more. So I think at the time they have 4D even for watching, 5D, that you can almost see the whole thing, you know, as if you're in there. That's technology. So its concept is from maths, and that's how your arrays are. As we go for the, let's see, when we get to the point, we'll still come back to this screen to look at how the indexes are located. So am I clear on that?
Yes.
Okay.
Yes, ma'am.
Okay,
Yes,
so let's go back to our, so now we have different data types, which we've talked about, the most common ones, your integer, your boolean. Now you have what you call unsigned integer. So, you know, in maths, okay, before I get to that story, there is a word you might hear if you go to read about arrays or in machine learning, tensors. Now, I'm not going to go deep into it because it's a very, huge topic that covers physics, maths, machine learning, artificial intelligence, and all that. But I think tensors, in a simple way to put it, is like a representation of not. So it depends on what you're talking about, whether it's particles or elements, right? And it has to do with the geometric coordination. So sometimes you might hear you will hear that a 1D array is there's a word for it, like I don't know if it's called a first order tensor. Yeah, so it's like a first order tensor, meaning it has only one direction. If you hear second order, that has 2 dimensions. Then you have third order tensors, that's 3. So just in case you come across that, it's talking about the same thing, but much more. If you now want to read about it, you can always Google tensors to understand from the mathematical point of view. Now, this, you have your integer boolean, you come across, you have your float complex. So the common ones, we've worked with integers, we've worked with booleans, we've worked with floats, we've worked with string. Objects, objects. So when you start working, I think in pandas we'll come across objects. Yeah, we'll explain that when the time comes. Time delta and date time deals with dates. So when you do your pre-processing or when we'll do data analysis, we'll touch that too. Complex float is still float. It's just that, most of these things are also understood by the computer based on memory allocation, how much memory is given to it. And we won't go into that. So it's the core computer science that talks about bits and bytes. We'll see part of it here, but that's more about the details of it. Now, unsigned integer is just when you're specific that you want the integer to just be positive. So integer by default comes with either negative or positive, so you can have -1, -2, plus 2, 3 to infinity. That's your integer, but unsigned integer is strictly positive. And so the allocation is allocated for just positive numbers in memory. So please bear this in mind. It's from here, you'll be able to also tell your array what kind of data type you want and how much memory space you want allocated based on the bytes or bits. Now, if you want to check what D type, so this D type I'm talking about is this. If you want to check what D type and probably the memory allocation for any array, just when I mean objects here, I mean the name of your array. So if you named it array 1, you just have array1.d type and it will show you what D type it is and the allocation. It should also be noted, okay, at the point of creation, you can also specify, you should specify. If you don't specify, it will give you a default. Like for your integer, you can assign 8 bits or 16. Okay, most of you don't have computer science background. You don't need to know in details, but bit allocation comes and they have 8 bits, 16 multiples of 8. Then you have 32, then you have 64, and then 128 and 256. So this, see as we work with it, what it's like. So this is like an image showing you for your Boolean, you have true or false stored as a byte. But then for your int 8, the allocation is this. So it can accommodate from -128 to 127 number. When it's int 16, this is what it can accommodate. So what this helps you with, if you're working with numbers and you already know maybe the range, it doesn't make sense if the range of what you're working with is within this. It doesn't make sense assigning int 64 to it. That's a waste of memory space. You understand? So if you know such, you can assign what can hold it or contain it and save memory space for other things. Then you have, this is your unsigned integer. So you see similar, but you can see there is no negative. So it doesn't have it doesn't accommodate anything less than 0. So it's 0 to 255 for the uint 8, uint 16 is 0 to this, and if you also notice, it appears because it doesn't hold negative, you can see that it's almost double of what you have here, because it's the same, it holds the same, like one, how do I explain it? The space given is the same, but because it doesn't warehouse the negative, so that space that is meant for this negative side is added to the positive. So that's why you have 0 to 255. This is double of this, same thing until it gets to the 64. float holds fractions, we know, and float holds have precision sign float, so you don't need to, but just know it's the same memory allocation space for this. Now let's go on. We talked about packages. So this is easy for you to understand. I'm just importing Numpy library package using an alias NP. So instead of us doing numpy.np is just a short version so that you don't get confused. So here I'm loading it now. And let's look at one-dimensional array. Now, mind you, what I'm using here, so you have inbuilt functions method that came with NumPy. So NP, this .1 is just, I just want to generate ones. That's the figure, the number 1 for for explanation's sake. There might be something you want to generate it for. I can't think of any, any case, but it just generates ones. You also have np.0 that will generate 0 for you. This 6 is just telling it generate 6 ones for me. That's 1, 1, 1 in 6 places. Now, this is how you put the parameter. Remember when we talked about functions? So in this case now, what is this? This is what? Can anybody remember what type of method we are passing our arguments? What is this called?
Set.
Anybody? Sorry?
Set, sir. No.
Set? No. This is a keyword argument. Remember, we talked about keyword and positional. So this is positional.
Okay.
Yes.
Okay.
And this is your keyword argument. So NP, because you're giving the value to the name, you understand? This is a parameter name and you're giving the value together with it. So this is you telling it, okay, when you're creating these ones for me in 6 places as a one-dimensional array, I want you to allocate this space. That's basically what we're telling it, 8 bits. If it's 64, you put that means 64, meaning you're expecting large numbers, but 1 is within, you understand, within the minus 127 and 128. So you allocate 8 to it. So let's run this and see what it looks like. This is what we have. It tells you, okay, when you call the variable or the object, it tells you it's an array. This is the content. These are the elements, and it's of D type, integer 8. You can also create an array from a list. Just make sure the list contains the same elements, the same type of elements. So this is it when you create it from a list. Now, this one assigns, if you notice, I did not specify what kind of, what I want for the D type. So it will assign a default one. Let's see what we have here, what it assigns naturally in 64. So that's the default it assigns when you don't specify. So now I want to be specific. I want it to allocate 8 for me. It's just ones I'm dealing with. I'm just dealing with small numbers. So why waste memory space? So I do that and I'm checking the one I assign here. This is D type int 8. So this is a simple way to check your object.d type tells you what kind of data type it is and the space allocated to it. Type also just tells you what type of object you're dealing with. And here we have it that it's a NumPy array. To check the dimensions, so you can use .dim, what is like number of dimensions if I want to check. So this one has 1, just 1. Now, see what we're talking about, performing arithmetics on arrays. List, we wouldn't have been able to do this with a list. But with this, if you notice, where is our, let me see, let me call that so that it's close to us. So let me call this my int underscore list. This is what we have. So unlike your lists, for us to perform this, would have had to do like an iteration where we now pick the first number, multiply it by 4, put it in another list and like an iteration. But NumPy arrays, straight up, you see 4 times this, it just multiplies everything. So I want you to also imagine, remember this is an open source package created by people. So someone must have taught, right? This is how it was done before using list. You have to iterate it using those. So someone sat and now wrote the same script, you know, everything, put it together, that it becomes a package that instead of you now writing it a call. So I'm sure if you are able to access the makeup, you understand, the code that represents your arrays or contained within your Numpy, you know, classes, you'll find something similar to such being the foundation of it. That's just my assumption. So it multiplies and it just gives it to you in the list, the same list format straight out. The same thing you can do -2 for the same thing. This is it. So 5 minus 2 gives you 3, 9 minus 2, just the same way. So you see, it saves time, it saves you space, and it's faster. Yeah. The same way we access a list is the same way we access an array, especially a 1D array, straightforward. So you have, mind you, Python starts with index number 0, unlike some other programming languages. So don't forget that, please. 0 is the first one before 1, 2, 3. So if you're trying to access something like this 0 here, you know, these are original lists. If I'm trying to access number 2, that's index location 0, 1, 2. So 3 should give me 10. And that's what we have here. Now, if I want to create floats, I have to be specific. And this is how you specify np.float. This is the space I want 16. I want to allocate 16 bits to it. So I'm creating a one-dimensional float. Now notice this gives you 1 point. So this just tells you the decimal. And any NP array that is created as a float can hold a decimal. Now, if at the point I'm adding elements to it and I add integer, automatically it will be converted to a float, because that's, as far as you know, that's what it's going to hold. So it will make it a float. Okay. Now let's try to access element number 5 and see how it comes out. So 0, 1, so it's just 1. Yeah, it's going to give us 1. You see 1.0, so it shows you it's a float. Let's create a string one, a string array. Now if I want to call it, so this is what it looks like. I want you to notice this is different. And so it's even consistent in the way strings are read in Python. So even the D type for it is also enclosed within quotes, unlike others. Now, this thing means Unicode. And this number, I think we'll still come across is this number tells it how many characters. Now, we're not talking about strings. Characters make up a string. So like Ada here is a string. You can call it a string, a word. But characters are, when you now separate it, A is a character, D. So this under U, that's Unicode, the U is Unicode, is telling you that this array can hold only strings of 5 characters at most. And it begs you to wonder how. So if you notice in my array, when I created it, I didn't specify what I want the Unicode, you know, the bit allocation to be, but it just checked and automatically detected the highest number of characters that made up a string or a word there, and just assigned that, meaning it's accommodating that. So anything from that highest all the way down, it can take. We'll also see when you try to put something different, what the response would be. So it's telling you it's a D on the less than Unicode 5. Adding a value to string, just the way you access your list. So I want to add an item or replace an item at position this. So this is what we have here. We replaced Amina, and it's still the same. Now, what I was saying about the Unicode and the number, let's try to put a word that is more than 5 characters and see what happens. If you notice, it will take the first 5 characters. Anything after 5 characters, it disregards. It can't, so it slices it and just retains the first 5 characters. So what I can do, if I want to add more things, or I want to add a larger, you know, word with larger number of characters, I'll have to change the D type to accommodate, you know, more characters. And it's similar to, yeah, SQL too. Like if you're creating a database, you have to specify how many the allocation you want. And because like names, when people create forms, apps that have to do with forms and that takes in names, because they know people's name can be as long as, so most times you see that they'll make provision for 50 characters. So just take first name and second name. Sometimes it's like some even make up to 60, 64 characters to be able to accommodate all that. So when you're doing certain things, these are things that you think about during your planning phase, not when you started coding. So these are things like in your pseudocode, as you're identifying the steps to take, you are also considering the component, what will make up those steps, details, you understand. Oh, imagine when the person is providing information, how would it be if I'm extracting this? How will my information come out? If that information coming out is going to serve as an input, how would it be fed back? So those are things you need to form the habit of thinking anytime you want to work on a project or you're writing a code. Think beyond just, typing your codes and seeing, it works. Aesthetics, output matters, input matters, how it goes in and how it comes out matters very well, because a wrong input can mess up your whole analysis. A wrong output can also mess it up, even though your code is, working fine or functional. Now, this is here, we're trying to increase the allocation for how many characters it can take, and we're increasing it to 20. So run that. Now let's try, this is a name of how many characters? 1, 2, 3, 4, 5, 6, 7, 8. Space counts 9, 10, 11, 12, 13, 14, 15. So this should be able to pass in here. So you see it's within 20 characters. To check the current, now I have another one I created, and this I assigned 32 to be able to take 32 characters. So I run this. And here we have is, yes, well created. So it takes in. Now let me try to add or replace with this long name. And I think this is 32 on the dot. So let me run this. It works fine. Now let me add space, a white space behind. And let's see what happens. Just pay attention to the output, please. Can we see it doesn't add the space, because as far as R makes the 32nd character. So anything after the R, it can't take it. Let me even add another thing, senior. Let's see. It doesn't take it, it stops there. So except I increase it to 64 or 128 or 256, that's when it can take anything more than. Okay. Checking with Boolean result, the data type of an array. So what I'm basically asking here is, first of all, it's going to check the D type for my integer 1, and that one is integer 8. So I'm just checking, is it equivalent to this? That's all. Is that the D type of int1, that's object, is it equivalent to this? And it's false, because that one is 8 and this is 32 I'm comparing it with. Another way you can also check is my string 32, I'm checking, is it equivalent to, so you see where you can use all those things we learned about comparison, logical, this, where you can start applying them. So they all work together. You can make comparisons. You can check if something is in something. You can check if something is equivalent to something. You can check if it is less than or greater than. So if I run this here, I have false. It's not equivalent, but if I put 32. So if, let's say you're working with a data set that you don't know what, makes up that particular series I was thinking of then when I was talking about data frames and arrays. So you don't know what that array contains or the space allocated to it. You just want to find out. So if you don't want to do D type, or for whatever case you're trying to solve, you can make comparisons. You're trying to find out, what they are made up of. So here I have false. What do we have there? My 32. True. So I'm comparing this to this. Now, so this is different. This is actually different. This, I'm surprised anybody noticed. This is checking the type based on it being an array. though this will still give you false, but that's checking if it's an array. So this is, if I add that type, then it's now, I'm asking it, is array equal to, because the result it will give me is array, that it's an NP array. Is NP array equal to this? Definitely it's going to be false. So also, guys, I need you also to start learning to be detailed, pay attention to details, little things like that. I will want you to, sometimes I might put it in there just to know if you're paying attention to details or you're just going with the flow. Now let's go to two-dimensional arrays. You create it with rows and columns. So have that imagination like your Excel sheet, rows and columns. And just the same way, I think, have we talked about anything that deals with rows and columns in index? Class, have we touched anything like that? I don't think so. Okay, so please, let's pay attention at this stage. Now we're going to look at how you can call specific elements that are contained within two-dimensional arrays and three-dimensional arrays. The concept is what you're going to also apply when you start working with your data frames. It's also like your Excel. If you're trying to get a particular cell on a particular row, on a particular column. So I'm trying to create, using just ones to create a two-dimensional array. This is what it looks like. And I assigned integer 16. 16 bits is what I want allocated to it. Now, this is how you assess elements in a two-dimensional array. So I'm going to share my screen again for the whiteboard. Let's see. So this is what it says like. Let me get a new page. You have a two-dimension like this. I have one. And I have 4, 5, and 6. This is your row. Remember, this is your row. These are your columns. Okay. So with this, when you're calling it, your row is specified first, and then your column. That's the sequence. So in this case, our index location, remember this is 0, this is 1, and this is 2. For your column, we have, no, this is for column, please. This is for your row. Is it clear? Because for your row, we have, this is row that is on index location 0. Then this is the second row that is index location 1. Your row, this is the direction. So your row is checked like this. These are rows. So this should be index location 0, 1, 2, all the way to probably n. Column is this direction. So you have 1, you have 2, you have 3, you have all the way to n column. So you have, this is 0, 1, 2, 3, all the way to n. Is it clear?
Yes, ma'am.
So in this context now, if I'm trying to get this item, I'll first of all consider the row location. It's on row what? Index location 0. So it's at 0 first of all. So it will find the row first of all, which is index location 0, and then find what column it falls in, which is at index location what? 1. So to call that, this is what I have. 0 and 1. So let's also talk about the 3, when you have 3 dimensions. Okay, no, when we get there, we'll look at that. So please, this is how you call 2 by 2, two-dimensional array. Your row and the column. The row and the column, the position, the index location starting from 0. So let's look at practical So if I'm calling for this now, okay, everything is 1, so it won't make any difference. Yeah, we're going to get 1. Now, for your NP ones, if I'm using 0 or 1 just to create, multiple ones, mind you, here, nobody noticed that you had 2 values passed here as parameter. So this is also telling it, I want 4 rows and 4 columns. The same way the same concept of row coming before column to call them to. So you're just telling it, oh, create is 16 ones, basically you're creating 4 by 4. It's going to hold 16 ones, but you want 4 rows and 4 columns. I can actually also change this. I can say I want 5 rows and 3 columns. Let's see. That's what you have. So 3 columns. So let's leave it at what we had as 5. So to know that the column value comes after the row, the first is the row, then the column. I'm just trying to create floats here, the same thing. Now, if I want to get float element 2, I'm talking about row 2. So 0, 1, 2, that's this 3rd row. And then index location 4, 0, 1, 2, 3. There is no 4. Let's see if it's going to tell us. It should give us an error. Index 4 is out of bounds for axis 1 with size 4. We'll still come across what this axis 1 means. Now, for my floats, see what I want to do. So I want to replace one of the values here at row index location 1 and column index location 3 with this value. Ideally, this should come at, this is 1, it should be here at this spot where my cursor is. So let's run it and see where it's going to place it. This is the infinity. And we also know, you have infinity. Infinity is like, infinity is infinity. Numbers are represented when the numbers that we've not counted the last numbers on Earth yet. So infinity is used to represent something that has no end, kind of. So this is considered, as far as this is concerned, infinity with so many, what do you call it? And mind you, even if this was smaller than this, I won't be able to accommodate it. I don't think within float 16, I will have to, either it gives me an error or it will probably slice it or tell me to increase it. Now, let me show you what an unsigned integer is, where you can't pass a negative value, you can't hold a negative value. So I created 5 ones in 5 rows, 5 columns, and I assign an unsigned integer 8 bits. Now I want to change one of them to -1, -6. Let's see what it looks like. Now this is what we have. So if you remember, let me see, if you remember when we did, I'm just giving you a concept, when we did pop, when we worked with list, we said, let's say I have a list here, and we had said 1, 2, this is my list, 3, 4, 5, 6. And we have said when you say pop, or when you say give me item, this is index location 0, 1, 2, 3, 4, and 5, that it should give you an item of -1. It starts from here. It's a reverse, like it starts from the back and it gives you this value. If you say -3, now it's going to give you 1, 2, 3, this value. So consider it from that concept. So we have that. We agree that your unsigned integer, int, like 8, holds value 0 to 255. Can be 256, yes. Because it doesn't hold negative, unlike its counterpart, that's integer 8 itself holds from -127 all the way to 128.
128 to 127.
Okay, -128, because 0 counts for the positive.
Yes. 127.
So this is what it holds. So the negative is not accounted for here. It now uses that extra space to add more. Now, if you now tell it, to give you, you understand, to allocate for minus this. What it does is it starts from that end. So, you know, you have your 255, 254, 253, all the way. So it assumes that it's from here like a reverse, and so it's as good as saying this minus this. Do you understand? So that's what you will get. It's going to assign there because that's the number it holds. So it's going to assume that you're telling it, oh, reverse, like take away, literally take away minus this, 256 minus this, or 256 minus 6, 6 minus 10. So if you try it on your own with multiple numbers, even if you put that it should replace it with minus 10, it's going to subtract it and give you from the maximum number it can hold. So if you ever, for any reason, want to use that, bear that in mind, and that's how it works. It subtracts it literally for you. So this is what we have here, 250. You asked it for minus 6. So 256 minus 6 gives you 250. If I pass minus 20 there now for it to assign, replace with, it's going to give us 236. 256 minus 20, 236. But when it comes to regular integer or floats, it takes it because those ones take signs. So let's say printing them, see, it replaces it for you minus 4 minus 2. It takes negative and positive, but unsigned integer cannot take negative. Rather, it will carry it out like subtract for that particular position you asked it. Then I'm trying to create a two-dimensional array, but string array here. It's just the same way the other ones work. This is what it looks like. Automatically, it checks the highest number of characters in a word and it assigns by default if I don't specify. So the 7, I'm sure it's 7 we have, which is Adrian, 7 characters. So it assigns Unicode 7. That's the maximum it can take unless I change it manually. Now let's go to 3D. For our 3D, we have, like I say, sheets. So this is what it looks like. So this is your first sheet, second one, third. Then for the string, let's run a string one, the same thing. So for this one now, it's a 3-dimensional array, but with 2 sheets of, you know, the 2D array. Unlike this one has 3. So in this case now, this first sheet, if you're talking about the dimension, this dimension, this is index location 0. This is 1, and this is 2. This one has only 2 sheets. Now we're trying to see what type it is. It will tell you it's a numpy array, both of them. Let's check dimension. You can use dot ending to check the dimension, and it tells you 3 by 3. So 3 dimension. This one is specific for dimension, which is different from number of rows or column. Dimension is how many layers of it do you have, where each layer is made up of rows and columns. So if it's 5 now, if you add more value, which you can try, and if you add more sheets, it's going to give you a dimension of 5. Okay, let me see. And then another thing I want you to note, the sequence, okay? Your dimension comes before row and column. So in this case, this 3 is telling it 3 dimensions, 3 rows, and 4 columns. If I change this to 5, you're going to end up having 5 sheets of 3 rows, 4 column ones. That's what you have, 1, 2, 3, 4, 5. So when you're creating if it's like this, your dimension always comes first, which is also different. Like in R programming, your dimension comes last. So these are the small things that people have to, get used to. Unlike Python, your dimension comes first before the row and then the column. In this case, now, if I run this is going to give me 5 and then 3. Which one did I do that? Integer 3R. Three. That's not a question. Then shape now gives you the whole structure. Like I said, the shape of your building, the structure, shape gives you what exactly it's like. So it gives you the full row, column, whatever it is that you have here. So in this case here, for my 3, there are 5 sheets of it, 3 rows and 4 columns. That's what you have here in the sequence. Your dimension comes for that's how many sheets, then the rows, and then the columns. So if you're using shape, you want to see the full component or structure exactly. So that's another word, the structure. You want to see the structure. What's mixed up, how many rows, columns, and how many the dimension it has. Use shape. D type is we're checking integer of 8 and 0, 1. So in this case, where do I have, because I use here, so here we used characters, not words. So by default, it assigned 1 bit to each of them. If I increase it to 2, by default, it will assign 2, the maximum you have there. Now there is something we call special values, your none. None means not a number. So in some cases, you might pull a data set you want to work with, whether you get online or you're given. And if you have nones there, it's basically telling you, especially where you have in your array, you have numbers, and maybe somebody puts in at the point of taking in data, now puts in a non-number value. It's going to recognize that as none. It could even be space, So once you've seen none, N, it's usually capital N, A, capital N sometimes. It means not a number. Then you have infinite. We already know what infinity is. Infinite, so it has no end. Here, I created an array by dividing by 0, and we know a number cannot be divided by 0. Am I making sense?
Yes, no.
Yes, a number cannot be divided. So it's just to highlight, this is just to show you. And mind you, my array here, how many I have? 3 values, 1, -1, and 0. And I'm trying to divide them by 1. So 1 divided by 0 is infinity, but it's positive. The -1 is still infinite, but it's negative. Now 0 divided by 0 is not, so that's not a possibility. So that's why it gives you not a number. These are things that can bring up such results if you're working on. Now I'm checking. So see, I'm checking, I'm asking it, is there is there something that is not a number, that's a none in this vector 2, which is made up of this infinite, infinite, and then none. And the first one is false, false, then true. Is none is already a function, a method inbuilt, I think, okay, is it in Numpy or base Python, which you will come across when we start working with data sets. So sometimes you have a data set that have missing values. You use this to check or sum up how many missing values you have, how many empty, spaces or incorrect information passed. When I mean incorrect, not in terms of words, but maybe space, or just we'll come across it, you'll get more familiar with it. Now, this is just a simple iteration for this vector 2. Mind you, my vector 2 is what? Infinite, negative, infinite, and none. And I'm just trying to compare it to see where you have infinite and where you have none. That's just what it is. I'm just asking it. So I'm sure if you look at this later on your own, you'll be able to figure this out. So I'm going to leave you to go through it. This is what we've done, iteration. So try to see if you can figure it out. Manipulating a special value. We have what's here? Infinite, infinite, and none, negative, infinite. And I'm trying to find the one that's 0. Okay, I'm adding 1 to it, to infinite, and it gives me still infinite. So special values give you the same, no matter what you're doing to them. Infinite, anything added to infinite will still give you infinite. You overwrite it. Anything added to none will give you none. So they override your normal numbers. Raised to power 0, infinite. You have infinite minus infinite, gives you none. So this is just for you to know. If I can't think of any use cases, but just in case, it's just to know for knowledge sake. Now I just created ones. Okay, I just created ones. Now, if you notice here, my ones, Okay, let me redo this. I want us to notice something to tell you the power of those special values. So I created a vex tree and I run my vex tree. It has already created it. Okay, I'll use another example to explain it. So what I did is I created ones and I just replaced the first one, which is our index location 0 with an NP none, that's none. This is how so you can actually assign it straight up like this. Yeah, it's its own kind of method. That's why you can even find is something noun, sum of none and all that. To find the sum of values of this one. Notice here, this ideally should have given me 1, 2, 3, 4, 5, 6. And if this was 1, 7. But the presence of this noun suppresses all the other ones. So everything ends up being none. Now, I want to find out the sum excluding noun. So what I'm saying here is without the noun, give me the sum of the rest of the elements. And this is what I have here, 6. But with the none considered, what do I get? I get none. Here, I created vec 5 and I'm giving its value, I'm giving an element the value NP none to assign none to it. The second one is 1 to 6. The types is the same thing, it's going to give me float. So by default, look at this, why I did this for you to notice. By default, if there is no none, by default integer, the numbers are considered to be integers. But once there is a none in your series or your array, it overrides the others. And none comes with float value, float data type, sorry. By default, float data type, and it's 64. It assigns by default. So unlike this one here that I have integers, they're the same except for the presence of none here, and they end up having different data types, float and integer. Conversion, so from what we've explained, you can convert. If you have integer, you can convert to float. If you have, so you now try some examples and see if you can convert float to integer. I don't think we should spend time going through that. Just try it out on your own with some examples. I have this here I created and it is integer 32 bits. I want to convert it to float 34. So all I just need to do is I'm telling it the D type of my new, that's this object, make it MP float 64. Let's see what the new type is. Float 64. It has changed it. Accessing string elements. We've already done our string here. Okay, let me call the string so that we'll know what we're talking about. So ST to the R. This is what we are working with. I want to access string elements within it. Can we see? So there's something here I want you to see. The way I wrote this, okay, this is a bit tricky. If you notice here, based on the precedence, I have, this is enclosed within the square bracket. Sorry about that, guys. This is enclosed within a square bracket. And as far as this thing knows now, it's considering this to be is a two-dimensional array and is expecting just rows and columns. And from what I did, I'm giving it more information that it needs. So here, can somebody try to see can somebody explain what you think we did here, the difference between the two? Anybody?
Hello, ma.
Yeah.
What I can say, the difference between the two is the fact that the second one has, comma 3 as the last parameter, whereas it's not in the first one.
And so why do you think that is? What difference did it make?
let me say the first one has, 3 items, whereby the second one has 4 items. 2,3 plus 3,2, 1, then 3. The second one.
So basically what this, so let me show you something. Here, what this is, as far as this code is concerned, everything I have here represents rows. Okay. Everything, then this now represents the column. So if you notice, it gave us values that are contained within the column that's the third index number 3. So everything here is made up of Uche, Tony, Abdul, and Matthew. But now extracting different rows at each time. So here we have row index location 2 and 3, which is Abdul and Matthew. Then we have 3 and 2, Matthew and Abdul. Then we have 1 and 0, that is Tony and Uche. Why I put this here is so that you get comfortable with not being confused by multiple, you understand? So because if you look at it at first, you might get confused and think, oh, I'm talking about multiple dimensions. No, this comma, so let me see if I can illustrate a bit.
I don't understand that.
You don't understand it?
Yes.
Okay, so we have this. And I have A, B, C, D, E, F, G, H, I, J, K, and L, right? And we agree this is 0, 1, 2, 3, 0, 1, 2. These are row numbers, row 0. This is column index location. Now, when you want to call 2, we agreed it's just the comma that separates, right? And what you have here is your column value, and then you have your row. Agreed?
Yes, ma'am.
Now, once you pass it, the way Python, because it looks at it general, like a bigger picture, and then probably breaks it down to now. If I have this, and I specify a column, and I have a list. So mind you, lists, once you have another thing embedded within the square bracket, is a list, meaning that means multiple things, right? So this is saying, yes, this Python says that multiple things. That's why to expect row and column, which are two parameters or 2 information. If you don't have a list within it, that means it's saying that, okay, maybe for the row, you want it to extract multiple rows. Am I making sense? So you can actually have this, a list here representing multiple rows, and then another list representing multiple columns. This is the major thing Python is working with to know, okay, everything here is row, everything here means column. Am I making sense?
Yes, ma'am.
So in this case now, I want it to extract multiple rows, but I want a particular order. So I can use this and say, okay, I want it to extract for me 2, 0, 1, okay? And then I want it to give me column 0. Can you try to guess what it's going to extract for me? It will first of all identify, right? Column 0. So this is solved. It will now go here. What is that? Okay. Row index location 2, I. So I comes first. What is that? 0, A. A follows. What is that? 1, E. That's it. I can do the same thing and say, oh, I want everything on row 1, index location 1, but I want multiple items. So once there's an embedded, this is a list. This means multiple items, you understand, to be selected. And I want what? I want columns in this order, 3, 1, and then 2. What I will have is it's going to consider, sorry. It's going to consider row index row, that's 1. Then what is in column 3? H.
H.
Okay.
F,
What is that 1? F. And what is
G.
that 2?
G.
That's it. So you can even have it more complex now. What you understand now? So when you have, I want it to section it out for me, I can decide. So based on the same thing we just talked about now, I can say I want it to arrange it for me in like a 2 by 2, where it will hold, you know, a value here, a value here, a value here. What do you think I would do? And let's say I want to get all of them from one column. I can decide to extract them. I'll tell it how it should. I'll say, okay, for this, I want everything to come from, you know, column 1. But for my rows now, I want my rows arranged. I want 2 rows. So what do you think? That means within my rows, this is already a list for my rows, right? I will now have another list. So this is just about indentation. Does this make sense?
Yes, ma'am.
This first bracket represents, you know, anything rows. Within the rows, because I want to now have 2 rows, I'll section it again and then provide, okay, I want 2 items in each row, and I'll specify maybe I want from row, I want 1 and 0, and then I want 2 and 1. What would this give us? Can somebody tell me? What will be the first item here?
F.
F, okay.
B.
What? B.
B. B. J. F.
Exactly. So that was what we had represented in the code. You can increase it as, what matters is make sure, you know, your brackets close. So if I have another dimension, you know, when you have a third dimension, what comes first is your dimension, right?
Yes.
Followed by your row, followed by your column. So make sure that they are represented properly. If I now want more than one dimension, I will enclose a list, right? If I want more than one row, I can use a list. It all depends. I can even, if I want more than one row within here, I'll now specify depending on the number of rows. So this is a manual way of doing it. I just want you to understand the flow. If I want more than one dimension, that means I'm going to have another list. Okay, you know, for dimension, I won't need to, because if it's 3 dimension, I want 2 out of it. All I need to do is specify maybe 0 and 1. No need for an inner bracket. But this one, because I want each row to have a certain number, I'll use a list again to specify. So that's what we have there, basically. That's what I did here. So why it didn't work here is because, you see, as far as it can see, it is confused. Do you get? So it doesn't know whether everything here represents a row, or I'm trying to say, okay, let this be dimension, let this be row, and let this be column. So out of the 2 options, there is no dimension to this, it's just one. So meaning that is ruled out. So that's the intelligence also behind this thing. It is ruled out. So this cannot be dimension, row, and column. Now, if it is now row and column, that means either there's an extra element that's not supposed to be here, or one of them is not accounted for. So that's why it's giving this error. Too many indices for array. Array is 2-dimensional, but 3 were indexed. Can you see? Meaning I'm giving it for 3-dimensional when it is 2. So this comma now tells it, okay, everything here represents row, and this is my column, and the answers. Now, sometime, if we start working on data, you get to a point where, just as habit, like I do that, if I'm working on a project that has to do with multiple aspects. So let's say you want to do your analysis, which has to do with visualization, and then you're going to use the data maybe for machine learning algorithms and some other things. there's a habit of, I make a habit of copying my data sets because it's not the same data set I use for, I would modify or pre-process for machine learning I'll use for EDA. Now, that's when you will work with the copy function. Here for arrays, you can make copies, but usually in the regular programming, you can, I think R or some of them, you can just assign directly. So you see this case here. I already have one existing, which is string to the array, but I want to duplicate it. So I try to assign it directly, which makes sense. Assign this to this. So whatever I call new string to the, it will give me the same values of string to the array. And that works. So if I call it, yeah, it gives me. But let's now try manipulating it. That's when we would know if what we want, because what I want is, my intention is, I want to copy it so that this original one, I don't touch it. Anything I want to do here, let me just do to this. And I can always use the original one for something else without changing the values. Let me plug my laptop. But then I realized that, okay, here, I just changed the name here, which is at 2-3, row 2. So it should be this third row, Abdul. So I'm trying to change Abdul to Brian. And it's in the new object I created, right? So let's run the two and see. And you find out that Brian was changed in the two of them. So as far as this is concerned, right? You just, I don't know how to put it. It doesn't copy and separate them. They're not independent of each other if you use this method. They're just like a mirror of each other. So whatever you do on one affects the other one. How to solve that where they are independent of each other is to use the copy function, the copy method. So I do the same thing. I created another one. Now let me modify Matthew to Joshua and see if it's going to affect the two. I've copied now literally. So you see Joshua is changed in the new version, but not in the original. So please bear that in mind if you're working with arrays, when you're working on your data sets or you're performing ML, this thing. If you want to duplicate, use .copy. Any file you're working with in use .copy. Don't just assign. If you ever get to work with R, you can assign. But Python .copy is what will just make them two separate entities where something done on one does not affect the second one. All right. View is another thing that is just like that direct assignment. If you use view is just giving you a mirror. So anything you run affects the second one. I changed Brad, it changes here. Following Joshua here. Oh, it's the same thing. So Joshua, Josiah, I changed Josiah index and it affects it. Slicing an array, we talked about slicing lists. When we did work with list and dictionary, we can slice them, meaning you can extract a part of it you want. So our 3D array, remember, this is what it's like. What is the shape? It is 2 by 2 by 4. 2 sheets of 2 rows of 4 columns. Extracting it. Now, please look at this carefully. I think we also did this, yes. So I want to make a copy, but I just want to extract just some of this. All right. Now let me see. Just a minute, please. I think this should be very clear. I don't know if we need to. Let's just quickly run this through. We have A, B, C, D, E, F, G, H. And we'll have a second one. I, J, K, L, M, N, O, P. Remember, this is the first sheet. Okay. This is the second one. Then we have, just to make sure. This is 0, 1, 2, 3. This is 0 and 1, 0 and 1. In this case, let's say this is X. And I want to call object X, but I want to get specific ones. If I do get for me X, and mind you, this is subscripting. I told you if you want to access the data within an object, that's where you use the square brackets, and you specify rows, column. But in this case, we have 2 dimensions. Your dimension comes first, your row, and then you're just like the way you create it. So if I say 1, 2, 3. What I'm saying is this second one, this one, row, the row with index location 2. Oh, which doesn't exist in this case, you see. So this is going to throw an error. This will throw an error, yes. So if I change this to 0, talking about this row. So it's going to pick this row in this sheet. And then third column 0, 1, 2, 3. So it's going to give me L. Now I might want to take more than, like we did the other one, a case where I just want random selection. That's when I use this and I specify the index location. But what if I want a range? So let's say I want to cut out this. That's what I just want to extract. Basically, what I'm telling Python to do is I'll say this sheet, which is 1, the way you use range, and this is what you use normally in range, the column. I'll now say rows. I'm doing from rows 0 to 1. So I can even, if I want, just if I want, specify, then this is 2 and 3. So I'm specific based on, because back to back, there's a sequence. If it's scattered, that's when you need to indicate which particular, but if there's a sequence, let's say from here to here, that means there's a flow sequence. I can say from 1 all the way to 3.
Elma, can you please repeat something again?
Sorry?
Can you please explain again, ma'am?
Okay, look at this. Sorry, I'm trying to put this up. This is what we have here. I know this is the first sheet, second sheet. This is 0, 1, 2, 3. This is 0, 1, 0, 1. And I say, give me from this first sheet, which is 0. Give me O2. And yeah, this is the part also, sometimes you can mix up if you work with multiple languages. Python doesn't, remember we talked about it, the end, it doesn't recognize the end value in a range. So anything you want should be before what you specify as the end. So if I say 0 to 2, that means it's going to give me just 0 and 1. If I say 0 to 5, it's going to give me 0, 1, 2, 3, 4. You won't include the end. Yes. So that's one thing you also need to remember anytime you're working with Python. So here I'm extracting 0 to 2. In this case, we have 0, 1. So this would work because there is no third row. Do you get? So it's going to extract index location 0 and 1 for us, which in this case is here. From here, the whole of this, but now specific columns of 0 and 1. So it's going to cut out A, B, E, F. This is what I'm talking about again. Let's repeat it with illustration. Is that okay?
Okay.
Where's my whiteboard? Okay. This is what you have here. This. In this case now, it's going to, because it doesn't take note of this, it's going to give me for index location only 0, then it's going to give me index location only 2. If I specify X 0, 0, 2, 2, 0, 2, 3. It's going to give me the first sheet, right? Which is this.
Yes.
Then it's going to give me index location 0 and 1. This is going to give me index location 0, 1, and 2. In this case, let's focus. So it's going to extract, it's first of all, it's going to pick this sheet, okay? It has satisfied this request. Then it will check for rows 0 and 1, everything here. So this is 0 and 1. It has satisfied this. Then it will look for items, elements at 0, 1, 2. So it's going to check this. So this is what it's going to give me now. Is it clear?
Okay.
To give me
Okay, ma'am.
Is it clear now?
Yes, ma'am.
Yeah.
Okay, so this is what it's going to extract for me. This is what you call slicing. You can either name the, and so if you now have multiple elements you want to pick, if they're within, they're arranged in a sequence, just use range to call them. But if they're scattered and you know what they are, then you can call the individual index locations one by one. The shape of the new, this thing is going to be 2 by 2, exactly. To get the first, now if you don't specify any value, and if you use just column, you're telling it, give me everything. Once it's like this, you can't leave it blank. If you don't specify, you're saying, give me everything. In this case, it's going to give us everything. So the only thing you're using to subscript or to filter is the dimension. So you're just saying, give me everything in dimension 1. Every row, every column, but only dimension 1. If you do something like this, let me see. If you do that ST, which is basically everything, it's going to give you everything. That's it. So once you leave it blank, you just use it, you're saying the whole range, everything that exists there. But when I now add values, 1, so this is going to give me both. So this will give me, if I change this, it's going to give me the 2, but sorry, it's going for each sheet, row 0 and 1. So it's going to give me all the row 0, sorry. So just 0, 0 here, but column. So it's going to give me A and I, let's see. That's exactly what it's giving you. It's the same concept here. I want to replace, so you can use the same method to replace an item. So in this case that we have, I'm telling you in the first, that's the second dimension for the second row, because this is index location 1, and for the third column, replace it with Z. So that should be, where is it? Second, but where is it again? 1, 1, 2. So 1, the second row, then 2, that should be 0. Oh, so replace O with Z. Let's see if I, yes, so that's why you have it. You're replacing O with Z. Now let's look at string array that has 3 dimensions. This is what we have. So we're just trying to manipulate it. That's basically what we're going to be doing. To extract a value, mind you, this will give you everything, which is all the sheets, all the dimensions. This will give you all the rows, but I just want column index location 0, which is this line. So I just want this line. And I want, when it extracts it, to take it, as in to make a copy of it and assign it to this. So my object, which is array string 2, will hold only this first: Joe, Margaret, Wayne, Max, Harold, Bob, Wayne, Lucy, Joey. That's what it's going to hold. That's what we have: Joe, Margaret, Wayne, Max, Harold, Bob, and then Wayne, Lucy, Joe. So just this first, the first column, which is index location 0, but every other thing. Now you can filter using comparison. So I want to check, let's check, run through this. Anywhere, if it finds bulb, there's anything that's not equal to bulb. That's what I'm trying to get here. And this is what it's giving you. So it's from here, anything that's not equal to Bob. So he gave me everything but Bob. I want you to notice something. Remember, I told you if you want to subscript means extract the data itself. To extract the data itself, that's when you use this square brackets. Square brackets after, so if you specify your object name and the square bracket, you're telling it whatever condition, whatever that is within that square bracket, pull the data for me, subscript that, bring out the data for me. But when you don't use this, let me share the screen. If I have my object name is, let's say array 1, this is my object. And it is made up of a list. Let me see if this will help with the example. 5, 6, 7, 8. Okay. And I want to subscript this by using a condition, anything that is greater than 5. Now, 2 ways. If I do this, array 1, and then array 1. Or I do array, no, I do. These are 2 different things. This one, what this does is it just checks within this and it will extract values that are, no, sorry, this is not. What this will do is it will go to this array and it will check. Is 1 greater than 5? False. So I'm just using a short form F. Is 2 greater? F. Is 3 greater? F. Is 4? And then true, true, true. That's what you'll get. But this, the presence of this now, what it does is, the presence of this tells it that I need the data that matches this condition. So give me back the data. I just don't want you to check. This is just to check. This is just check. Comparison to check. But this means after checking, give me the data that matches, or for which that condition is true. So what it does is it will first of all process this, right? So when it processes it, it will now give me back the data. In this case now, it's going to give me 6, 7, and 8. So they're similar, but they give you 2 different outputs. This just compares and either prints it or just outputs it for you. But once there is this square bracket, now you're now saying, okay, check this condition and give me back, that's bring back to me, or not output, not print, but bring back to me the data that satisfies this condition. So when you start working with data sets and you want to extract, to bring out the data, not to just compare and know if it's true or yes or no, to extract, make sure your condition are within this. And so what you're telling it is, when this condition, when you check it against this. So when you check it, go back to this and find all the values, all the elements that meet that condition and extract them for me. This is just check and tell me if true or false. So if you're trying to access the, what do you call it? The data itself, please do not forget to use that subscript brackets, which is the square. So like I said, this just compares for you, but this compares and extracts the data, the elements that meets this condition. That's why you have this name here. And this just tells you true or false. So what this does, it will check the first one. Is Joe equal to Bob? False, false. sorry, okay, not equal to. Is Joey not equal to Bob? So the only place you will have false, that Bob is not, is where Bob is. All right. Concatenate means to add. So you can add two arrays. In this case, instead of me adding, I created there's an existing array, and I'm at the point of concatenating, I'm adding a new array. I'm creating and adding a new array to this. Now, axis is a parameter that is asked for. So it's being passed here as a keyword argument. And what this simply means is when you provide your axis to be 0, you're saying, I want whatever you're doing to be done on a row by row consideration. But when it is 1, you're talking about column. 0 means row, 1 means column. So in this case here, I'm telling it, hey, concatenate these two arrays, but by row. So if this is what I have, I want it to add Fred, Jeremy, and Donald here as a row by row. But then if I'm to assign to add it by row, sorry. But if I'm saying by column, that means I'm telling it add it by column. So if you run this here, we can see by row it's considered. Then bear in mind, if I'm adding this, you see, I have the same number of elements as the columns, meaning an item fills up in each column. So if I don't want to add by column here, let it be a column, I have to consider the number of elements. And in this case, there are 4. But if you notice the difference, please see the difference in the expression. Can somebody tell me can anybody pay attention to notice? Or does anybody have any observation? Sorry, that's a better word. Is there any observation? Any difference between the two? Even though you've understood the concept, any difference between the two? Anybody? Can anybody attempt? Look at the two codes, 111 and 112. This appended or concatenated by row, this concatenated by column. I've explained the number to match it. So here I have 1, 2, 3. Here we had 3 columns. So you have 3 items to fit into each column. Here we have 4 rows. We must have 4 items to fit into each row by column. But there's another thing I hope somebody might notice in the codes. Okay, let's not waste time. Let me show you what, if you notice here, that the items are here, everything is enclosed within 1 square bracket. So everything makes up 1 list and is concatenated, appended as a row. Unlike here, they are like individual entities that are independent of each other. And it's just the way, it's the same way you create your what do you call it, your array. Remember when we are creating an array, so let's say I'm creating an array, 1 dimension. I have my list, right? Everything is enclosed within a square bracket. If I'm creating a 2-dimensional array manually, all I need to do is give it another list, 5, 6, 7, 8. The first one will give me, 1, 2, 3, 4 as a list. Adding this now gives it what again? This is what I have, which at the end of the day becomes this. Sorry. At the end of the day, when it is represented, this is what I have if I create this. So basically, each element, each list provided becomes a row. If I have another one now, I add. If I add a third one, 9, 10, 11, 12. it gets added here 9, 10, 11, 12. So it's the same way if you want to add anything. I have an like the one we did. We had existing A, B, C, D, E, F, G, H, I. And you want to concatenate like, okay. Want to concatenate, and we said, if my axis, if I specify my value and with axis 0, that means I want to add it here. So let's say I want I, J, K, L, right? It gets added here as J, K, L. But I want to now add, because this adds by column. Forget that it's a row, it adds by column because it will add J to one column, K to another column, L to another column. But I now want to add by row. I want a value added like this, like this, like this. Remember, for us to be able to create rows, each row is a list of its own. So that's why even if it's just JKL I want to add, my J has to be contained within a list. My K has to be contained within a list. My L within a list. My M within a list. That's the only way it can be added here. K, J, L, M. If you are creating multiple dimension or 2 by rows and column arrays, a list like this makes up a row. A list makes up a row. A list makes up a row. That's how it is by default. So meaning by default also, if you want to concatenate by column, when I mean by column, you want it to be a column addition, not row addition. Make sure that the values, anything that is to be added to any row has to be enclosed within its own list, just the way you create it. I don't know if it's clear. Am I clear, guys? Does it make sense?
Yes, ma'am.
Okay. So if you want to append, though in data frame it will be easier, but arrays, if you want to concatenate by row, it's just your one list is what you're adding as a row here, because it's going to add by column by column. But if you're now adding a column, you have to consider it's going to add it by row by row. Okay. Let's continue. Let's quickly get this done. So that's basically what this is. So running this added by here. More arithmetics. Okay, random. We've talked about random. This is just generate random numbers. And at the point of generating, I can decide. If you look at this now, if I run this, my array, the first one is just random number generated by itself. And I wanted to create 3 dimensions with 3 rows and 3 columns. And that's what we have here, this 3 by 3 by 3. That's what it created. And I'm telling it to allocate 64 bits. So it's multiplied by 10. So that's what I have here. My array 2 is the same, supposed to be the same with this, but they are random numbers. So that's why you have different values. Now, let's try to add. So it's just simple maths that can be done on them, which we've talked about. So in this case, I'm adding 100. So you can see 100 plus minus 9 gives you 91, and so on. 100 plus minus 6 gives you 94. I can divide straight up. You can do multiple things. You can multiply the arrays by themselves. So you can do it. Now, by the time you take your time to go through this, you understand why you're having none. So maybe where there is 0, it will give you none eventually. And the other ones will give you long numbers because of you see, this is raised to power. So first of all, we're dividing this array 2. Now, where is it? Array 2 by 4. And then raising array 1 to the power of whatever value is in array 2. So it's going to match each one. So in this case that I have my array 1 and array 2, what I'm doing is I'll first of all divide this by 4. So in this case, 6 divided by 4 is 1.5. And then I'm saying minus 9 raised to power. That's basically what I'm doing here. That's why you have this funny looking numbers. The ones that are not none will give you very high, either negative or very high positive numbers. So don't let this confuse. The linear algebra is just simple math that you can do with this. You can extract also based on this. In this case here, I have one layer of one row with 3 columns, which is straightforward. Transpose means to just change. So it's like transpose means to change something, the shape or the outlook of something by not anti-clockwise, but following a particular pattern. Maybe you understand better if I run this. So I have, this is 3, 0, 1, 0, but I want to transpose it. So my rows will become my column, while my column becomes my row. So it's like here, a shift. It's the same content, but it's just that it's transposed, just as the English word means. So if I transpose, it's going to give me 0, 1, 0 instead of, so my rows now, I now have 3 rows and 1 column. I can multiply it. And when I multiply this, it's going to give me, look at it. So it's going to multiply, in this case, 0 will multiply everything here, 1 will multiply everything here, and 0 will multiply everything here. That's why you have this here. I'm just creating a range 0 to, it doesn't consider the last number, so it's going to give me 0, 1, 2, 3, 4, 5, 6, 7. Reshape. If I want to reshape means I now want to create 2 dimensions out of 1, or even 3 dimensions out of 1. So in this case that I have 4 numbers, 2 by 4 will mean 2 rows, 4 columns. So it will be arranged that way, and it's by row. So it will assign it first of all 0, 1, 2, 3, finish 1 row, and then go start from the second row. This I can also do it 2 by 2 by 2. So it will give me 2 dimensions with 2 rows and 2 columns. Now, bear in mind that if you want to do this, make sure whatever you're specifying is a multiple, or is it multiple, they say, yeah, a multiple of the total number of elements you have. So if I have 10 elements, I can't ask it to do 3 by 3. No, that will give me 9. What happens to one last element? So it has to be either 2 by 5 or 5 by 2. If I have 16, 16 can be 4 by 4. Or if I want 2 dimension, I can have 2 by 2 by 4. By the time you multiply 2 by 2 and 4, it's going to give me the 16. So that's how you can break it down. I can compare, is this greater than, it will give you Boolean results. You can subtract, you can multiply, you can compare. I'm creating another array of random numbers. Now I want to convert it to list. So these are methods and functions. And I remember I told you methods are functions that are applicable to an object type. So that class, in this case, our class is the arrays, and the things you can do with arrays specific to arrays. You can convert an array to a list. That's what I have here. So this becomes a list. But you see, so it's like a reverse of how you create it. So it's like me, if I copy this now and pass it as an argument to an NP array function, I'm going to get this. So this is like taking it back to origin. I'm just, yeah, that's a good word to use, origin. Flatten is also to flatten it out. If you have it made up, this is it. But in this case now, you see, they're not list. Everything is, so it breaks it down and all the elements are put together in one list. Unlike this one where you have 4 lists, each list is a row. So a row is a list here. It still maintains this structure to an extent, just that it's passed out in the list, but this one is flattened out totally. Empty means to remove everything within your array. So if I pass my array, it's going to be empty. Yeah, it's empty. You can populate it using fill. So I want to now fill this with a word Python. And this is what I get. So you can empty, you can populate, you can split. Split, so you specify how many splits you want. So in this case, I have 6 elements, but I want to split this array into 2 places. If I say 3 now, it's going to give me 3 arrays into 3 places. You can see. No, I said 4. Oh, if I want 3, send 4 will give you. This is what we have. You can search through an array to check if there's something that's so, if I'm trying to find if there are false here, I'm just telling it, oh, find or check through my array and tell me where you have the value I specified. So in this case, false. This is your index location is giving you, not values. This is index location. So it's telling you, okay, I've gone through it. At the third index location, there is a 4. At the 5th and at the 6th, there is a 4. You can sort alphabetically, or you can specify to filter. Okay. I have an array that is 41, 42, 43, 44. And then I have another array, true, false, true, false. And I just want to filter. Creating a filter directly from array. Almost out of time. In this case, I just want, okay, what we talked about comparison, yes. So if you notice here, what I did was I just created another variable that holds this. So anywhere I pass this, this is what is going to be carried out. And what am I saying? So this is as good as passing this within here. Remember, because I want the information, I want the element, I want the data itself, the element, not true or false. That's why I'm using a square brackets. If I run this, let me, okay, yeah, I printed the 2. So if I run the 2, see the difference again. Just running filler, that's this like filter array, just running it tells me Boolean, okay, is this greater than 92? What I explained earlier. But if I pass that condition within a square bracket for an object, I'm saying, okay, go to this object, extract all the elements that meet that condition. You will use this a lot when you start working with data sets. You can sum up values of an array. The first array we made, you can find the total. Now, you can sum up by column or by row, represented by axis. I've already explained what each axis is. So this is our array 1. This is what it is. Sum by axis equals to 0 is by row. So here, if you sum this up, you're definitely going to get 24. If you sum this up, let me see. 14, yeah. So this, if you add this up, it will give you 24. If you add this up, it's give you 25. Add this up 4 minus 4, this will 5. If I make this 1 by column, it will give you a different result. So it adds here, like this. Some last 2 columns, I can decide here. So this is me saying I just want to add up the last 2 columns, which is this and this. That's what it gives you, minus 4 and then 5. My original array, I want cumulative summation. I can, and specifying my axis is, if I'm adding by this, I want by the time it adds this, add this on top, add this on, so it increments. So I'll still have my 18, but the next one will be 18 minus 18 plus this. The next one will be, if you add 15, that's cumulation. I think we should all know what cumulative is. So like I said, minus 18, then if you add 21 to it, it gives you 3. So 3. If you add 15 to that, 3 gives you 18. If you add 6 to that, 18, it gives you 24. That's cumulative. You can find mean all, and you can also find mean specific by axis. So it will consider the axis and find the mean. So this is very useful in data sets too. Now there's something you call universal functions. Like I said, created for optimization. So look at this case now. If this is a regular list, if I want to add them, I will have to iterate through them. So I'm saying for I in and J in together, instead of writing a long, for this 4. What it's going to do, it's going to add 1 and 4. In this empty list, append the result 5. If we run it, that's what we're going to get. But Numpy has functions already that has optimized the performance and everything for you. So what it does, this add covers everything. It does the same work and just gives you your results straight out without you having to code it. The same results it gives you. Now, there's something we call vectorization. You can read up about it to understand the abstract or details of it. So let's say I have a simple function. This is a simple function that is supposed to check the values. So, you can pass this with a list and say, oh, check for if one value is, if the first element is equal to this or greater than this, return this for me or this. A single number will work. If we're going to pass this for a list, you have to use a for so that you can pick one number at a time to pass it. So if I write this function, I pass one single number, what would it do? To just check, is that number greater than 0? If it's greater than 0, it will return A, else it will return 0 for me. But though an array, we said array optimizes where based on the locality reference, it can pass the function, it can pass a function once throughout it. It doesn't work with user-defined functions like this. So see, it's telling you it's ambiguous. So that's where vectorization comes in. So it converts your algorithm from operating on a single value to a set of values. So it makes my array a vector that it can pass through that function as if it's a single value, and it performs that same iteration within it. So what do? You vectorize. This is a function to vectorize, to convert it to a vector. Vector means to vectorize means to convert to a vector. It's a set of single value that you can use. So when I convert this my function is passed through it. So to make it, to enable it to be able to use a vector list to work. And then I pass that same array through it. So my function has been vectorized that it can now handle an array. Maybe if along the line, if I think of a use case that this can be used, then maybe I'll share it with you guys. As I'm talking to you, I can't think of any. So in this case now, if I run the same function that has been vectorized, it will be able to do that for us. Look at it here. It didn't work here, but now it can because it has been vectorized. So because it has been vectorized, this array can easily be treated like the other ones. So what I'm sure also is that within the functions we're able to use, like the add, all those ones, such things might have occurred that we don't see, but we're able to use them easily on arrays. But then another thing also you have to consider, so yes, there are so many functionalities or ways of doing things in Python, but most times there's a way they say it might not always be the best. So you have to also be considerate of the requirements or the conditions surrounding your task. So if we are talking about, like we talked about lists, there are tasks you want to perform that lists will serve you better, more than an array, and it's a small task and you're not mindful of time or resources or optimization. But there are also ones that you want to perform and you don't even want to go near a list because arrays will do the job for you. So it's the same thing even with vectorization. So in as much as it will make it easy for you, but it takes a longer time because it will vectorize it first and then you pass the same arrays. So instead of that one step, it takes maybe like 2 steps instead. So there are cases that you have an alternative way, which is something like, so this is a very straightforward function that does the same thing. That does the same thing as this, straight up with your array. You make a copy of it and you're just, so what we talked about here, where you can use comparison. I think there's a place we did comparison here. Yes, so this is what we just did there. It does the same thing and it works with an array. You're just putting it in a function. Now, this is how you can check the time it takes for your function to run. So I want to check for the vectorized one, this one. How long does it take to compute it? 22. This should be milliseconds or micro milliseconds. And it does 1,000 loops each within the runtime. And let's see this other one. This is the second function. So you see, this is 21.1, this is 2.7, almost like 1/10. Okay, about 1/12 or so. And this does 10,000 loops each. This does 100,000 loops. So this tells you how fast this second one is. It takes like one 1/8 of the time it takes this one to run. So these are some things for, but yeah, maybe you might not have to do this, but on a larger scale, these are ways also they check before. You see apps that we use and so many things that are pushed out there. All those things are checked to be sure that they are optimal in performance. Okay, so I think this is all we can talk about for NumPy. Next week, Thursday, I think, or Friday, we'll be doing pandas, which is like a sister to NumPy. Both of them always go hand in hand when you're talking about data science and data analysis. Okay, guys, so do we have any question, anything we need clarification with? Anything? Are we good?
We'll go through. We'll
Okay.
go through the video.
Okay, all right. Then for the assignments, let me just address it briefly. I'm not giving you anything for this week until we're done with pandas. So I received, well, at least we all turned out, we turned in our assignments and the turnout was good. Not everybody though. So let me just quickly comment. I think I noted some things. Chinedu, are you here? Is Chinedu here? Okay, he's not here, so no need to comment. Who else do we have here? Do we have Philade?
Yes, I'm here.
Okay, so your game, he made his game more exciting. That I must commend him for. But you see, another thing is you went outside the scope. Okay, so the scope was, the concept was just use a list that has 3 numbers in it. He made his random, so he imported a random number generator, which will generate a random number, and then the person also guesses a random number, and if it matches, which is very good, you know, it's like another way to do it, but the scope. So I remember the last time I said, no matter how exciting or interesting something may seem, let us always try to know, even if you go beyond in asking questions in data analysis, make sure that the scope is addressed, because you can get carried away in trying to, you know, generate insights, and then you end up not answering or solving the problem statements, and you address other things but what, you know, you're supposed to do. So your game was very, you know, fantastic, but it's just that you were not within scope. You're not, yeah, you didn't answer exactly what was asked to be done. Okay, and yeah, I noted just was because there are some things I noticed with some other people's own. Another thing you also have to bear in mind, aesthetics. I also say it's aesthetics, which is something you will bear in mind when you start plotting graphs. Aesthetics is the outlook of something. How will the user feel? Or how will the output look to the person that is viewing it? Would it make it you know, easy to interpret, understand? Would it guide the person very, you know, easily, or would it confuse the person? So I noticed some of you, your own, by the time the person posts the first random number, it doesn't return a statement telling the person if, yes, it was a failure. So it just asks for the second one. I would, you know, to make it appealing or easy to use, it would make sense if I put in a number. If it's not jackpot, at least, right, you'll tell me, oh, it was a wrong, you know, wrong guess. Then ask me for another attempt, a wrong guess again. Then by the 3rd time, if I still guess wrong, you now tell me, oh, try again later. But just leaving it that way, it's functional, but it's not the best. It's not going to give the best user experience, or it's not the best interface as well. I think Philade was the only person that specified that, but you didn't do number 1 and 3 question. You only did the game. Okay, so then, yeah. Okay, then George, Okay, yeah, the question number 1. I can't even remember what was the question. Sorry, let me pick it up. Okay, so you attempted question 1, which oh goodness, which I said works perfectly well. Which works perfectly well, and then your number 2. Yeah, it was a mess. That was it was, so the way it was, can you hear me? I'm sorry, guys. I switched to another network. Sorry for that. So let me just quickly run through. Yes, please. So George, I want you to note, check if you check your code, right? Your BMI code was very good. Just that would have been nice to make the input dynamic, not static. So give a user the choice to impute it using that input command, not specifying it within the function. Then the second one, your second your second response or question it was kind of like a mess. Yeah. That's what I noted here. Then, okay, another thing I noticed you did, which some people didn't do, is for your BMI, you rounded off your figures. So it wasn't giving 18.999, no, you rounded it off to 2 decimal places, which is good. Then who else do I have here? Ifeanyi. Okay, Ifeanyi did a very good job with number 2. You didn't complete your number 1. Ifeanyi gave a very good user experience, yes, based on his number 2, which is the game 1, without going out of scope. But you didn't finish your number 1. You just basically printed what you have there without giving room for the person to ask for a user to input a name and search. Then for your number 3, which is the BMI, so you were one person that was able to write less number of codes. I noticed some people are probably still strong, which is normal when you start. At that, the place of doing comparison, let me see if I can open somebody's own. The place of doing comparison to check is risky to do it that way here. Okay, here. So the highlighted place, some people still do, and I know we talked about it when we did functions or the conditional statements, that you should avoid using if BMI is less than 18.5 and greater than this. It's dangerous. It can mess up your code and give you wrong output that you don't even know. In this case, you do either you do incremental or decremental condition or comparison. So in this case, started with lower, meaning it will check if it is lower. If that condition is not met, anything else is checking, has already considered lower than 18.5. So it's going to be considering from 18.5 above and up until 25. And if this is still not met, that means anything there is checking must be greater than 25. That's incremental. You can also use the reverse decremental, which we talked about in last class. I think that's it for him. Then who do I have next? I have Uche. So yeah, Uche, you did a very good job with your number 1 question. Number 1 was what again? Yeah, your dictionary was fantastic. The dictionary one about searching through names. I think someone else did. George, yes, George, that was very good too, what you did. And Chinedu, yes, Chinedu too, that number 1. It was 3 of you or 4 of you that did that number 1 very well. And I noticed you use different approaches, which is good. Uche, your representation was very good. The output, the aesthetics, how it looks was very, very good. Then for number 2, which is the game, yes, you did a good job too. Just that more information would have been better. So that's what I commended Filade for. If somebody puts in a value and it's fail or wrong guess, you need to let the person know and tell and give them the next attempt. And then when it's over, tell them, oh, that's, try again. Maybe they've used all their guess allocation. Then your BMI was also very good. It's just that you didn't round off the numbers. So if somebody does, it gives them long floats. Then there's another thing I want to point, which nobody used, is just to draw your attention to, is one of the ways you can use dictionary. You can access dictionary. So here, I noticed most of you, maybe the way you pictured it. So what you did was each line represented one individual's information. Okay, yes, it's a way to put it, but this is another way, which makes sense based on organization of data. So in this case, you have name, just like you have in your table. So if you open your Excel sheet now, you're not going to have a column representing one person's information, right? If you open an Excel sheet or a proper table with data frame, one column is going to be one variable. That's why you always have it that it's the same data type. So name is of character or string data type. So name is a key that will contain all the names of whoever that is part of the database. Surname is a key as well, which is like your column name that will contain names. Occupation, the same thing. If you have age now that is integer numeric, you see that it will be age and everything will be. So what you did, the danger there is doing it that one key contains an individual's information is you end up having a list that has mixed data in it. A time may come when you want to access it or carry out something on the list, you will not be able to do it because it has multiple data in it. Unlike this now, I can pass anything that can be done on strings will be done on my own. So that's the thing I noticed almost all of you did. You had the person's information being represented as a key. Now, to be able to access, in this case, the structure is, as I have name containing everybody's name, I already told you that each key, the values hold index position, just like your regular list. So in this case, gift is index position 0. Ifeanyi is 1. Adebowale is 2. That same way, if you go to surname, what it means, anything as index location 0 is for gifts. Anything as index location 1 is for Ifeanyi, and so on. Same thing with all the other keys. So the index, anything at index location 0 is for gifts. Anything at index location 1 is for Ifeanyi, all the way to the end. You can even now add more information as you keep going. It's just so you can identify each person's information by index location, just the same concept you have in your tables. So in that case now, if I want to extract one person's information, all I need to do is find the person that's name's index location and pull out every other thing in that index location. So that is what we have here. The person puts a name. All I need to do is I'll now check if in this list, and what am I using the key? So it's going to just search for it in this first key, which is name. If it finds the name there, it will extract the index for me. So in this case, if I put a name, it will check if it is in that list, it will get the index location using this function .index and just print everything, which I saved as index 1. So the same way we talked about calling a particular value, this is my key name. I want something at index location. If I don't put an index location, it will give me everything there. So if I run this now, and I search for, and I'm not there. So all of you got the function, like I said, the functionality for the specified task works, but think also about functionality beyond that. So in people that develop apps, they call it use case. You testing. You test with extreme use cases. So in this case, we're testing it with just searching a name. So however you put your function together, once it can give you that result, you're satisfied. But what if I want to do something beyond just searching for a name? What if I want to now perform some other things on the same information? That's when you now find out that, the method you used can work for A, but it can't work for B. Or it can work for B, but it can't work for A. So also think about that when you're writing functions. Think, it's not app we're developing quite all right, but also think of extreme use cases, other use cases. So you do it in a way it can meet so many use cases as much as you can think about. That's why index for me, using index number is the best, would be the best way. And it's a short code as well, just 2 lines of code. All these ones are just print of information, which on your own, you can also reduce this. So it depends on how you want to structure it. This is all we needed to do, this if statement and finding the index location. That was all the job. All right, guys. So you guys did a good job. We're not doing anything. I think you have a Streamlit assignment or something. I'm not sure, but we're not having any assignment up until next class, which is on Thursday. All right. So do we have any question, anything you need clarification with? Are we good?
I'm good.
Okay.
Yes, ma'am.
All right. So I wish you guys.
We are good.
All right. So I wish you guys a very good night and a very pleasant week ahead till we meet again on Thursday, I think.
Yeah.
All right. So bye-bye.
All right. Good night.
Bye.
Thanks.